So this is part 2 of the normal approximation. We're going to do some actual calculations that show that the normal approximation to the binomial distribution are going to be pretty accurate. So I set up this binomial online calculator. N was 50, P is 0.3. So we meet the criteria for normalcy with this distribution. You can look at it. It looks approximately normal. And we're going to just calculate a few different probabilities. Then we'll change these values, calculate another few probabilities, just to give you an idea that these are going to be very similar distributions. So I set N to be 50, P is 0.3. This will give us a mean of 15. So I'm going to come over here to this normal distribution calculator and set my mean to be 15. So this distribution right here is approximating this probability distribution. This one, of course, we can see is discrete. This one is nice and continuous. So our standard deviation, 3.24, that is also given, though we all know the formula for it. And then we're just doing a simple calculation. What's the probability of 12 or fewer successes? It's highlighting all of the area or the different bars that we're adding together. We get about 0.22287. So with the normal distribution, we want to now find the probability that x is less than or equal to 12. One thing that we should note, not a huge deal, but when we're not a huge deal for your class purposes, but if we want to get a more accurate distribution, if we used 12 as a lower bound on this distribution, if I typed in 12 here, it's actually cutting off right at 12. So this is where 12 would be. But then if I moved over a little bit more, all the way to 13, we can see that we're actually going to be missing a little bit of area. So what we'll end up doing is we'll use what's called the continuity correction. And we make this, we will always add half of the number of, add 0.5 to the number of successes that we're looking for. And that will make our probability much closer. So if I do 12.5, our area is 0.2202 compared to the 0.2227. So it's within less than 1% of an error there. Let's do another example. It might be easier to see if I do 15 here. When we're looking at this distribution, you can kind of tell that when we include all of that 15, it looks like it's going a little bit more than 50% of the distribution. And we can even see that the probability is 0.569, almost 0.57. If I made this 15, it's going to be exactly half. Okay, but you can see that this bar, because it has a little bit of width, it actually goes a little further. So we do that continuity correction, we make that 15.5, and our area is 0.5613. And again, it's very close to this approximation. So we were trying to note that if we were to just treat these binomials using the normal distribution, we're going to get very, very similar results. They may not be exact, but they're going to be very similar. We'll make another modification before we actually do the sampling distribution, but just to make sure that we can see how similarly these distributions are related. So let's change this up a little bit. Let's make n equal to 75. Let's make p a little bit bigger probability. Let's make it 0.66, closer to 2/3. We'll do the probability of success. Let's do, say, 40. Well, it's still pretty small. Let's make it 50. Maybe too much. Let's make it 44. 45. There we go. Okay, so about 16.457%. So we're going to use these values. We want to approximate this distribution with the normal distribution, which has a mean of 49.5. So our mean will be 49.5. Our standard deviation will be 4.102. Make that 4.102. So now this is the normal distribution approximating this binomial. And we wanted x less than or equal to 45. So here we're going to say 45. And again, 0.5 to make our results a little bit more accurate. 0.1647 compared to 16457. Very, very close. The larger our sample size is, most of the time, the more accurate our results will be. So hopefully, we believe that the normal distribution will approximate binomial distributions. Good luck with your homework. Let me know, as always, if you have any questions. See you next time.